Alright, so I think I'm recording. Let's take a look at the solution to problem number 13. And once again, I need to be aware of these order of transformations in order to do these problems. So when I look at this, first it asks me to identify the parent function. Since this x is being squared, I know that my parent function, the function that I'm going to start these transformations with, is x squared. The first graph that I'm going to obtain through my first transformation is there are no horizontal shifts to the left or to the right, because inside this squaring function I don't have a plus or minus some number. It's just 0. So I don't have any shifts to the left or to the right. What I do have is this multiplication, this 3. And it's bizarre in its behavior that when you multiply the input by 3, the effect that it has on the graph is a horizontal shrink by a factor of 1/3. So let's type out our answers here. So the parent function is the quadratic function, or if you put squaring function, that's fine. To obtain the graph of G1, my first transformation, I horizontally shrink the graph of f by a factor of 1/3. So what would that equation look like? Well, here f evaluated at 1/3 is saying everywhere you see the input, you're squaring whatever the input is. So we're squaring this 3x. That's what they did there. So now my final graph, G, takes the graph of the result immediately above it, and this -4 is a shift down 4 units. So obtain the graph of G, our final graph, you had to start with the parent function and then do a horizontal shrink by a factor of 1/3, take the result of that graph and shift it down 4 units. So to obtain the graph of G, shift the graph of G1 down 4 units, or 4 units down, however you want to describe it. Okay, so let's go to, like I have on problem 11 and 12, let's come over to this Desmos graphing calculator and kind of use it as a check of my answer. So what they want me to do, that mosquito's back. Boy, I'm glad I'm not in Rio with all the problems with the Olympics. All right, so my parent function is x squared. I'm getting distracted. So here's my parent function, my quadratic function. The description of that graph, we call it a parabola that opens upward with its vertex setting at the origin. And the first thing that I did was a horizontal shrink by a factor of 1/3. So this graph is going to become more narrow. It's going to squeeze in towards the y-axis, if I'm correct in my description of a horizontal shrink. So you can see that the blue graph opens more narrow than the red. And now for my final answer, it uses the graph above there, the one that's in blue, and what does it do? It moves it down 4 units. So I've got the previous graph is shifted down 4 units. So you can see that that's exactly what happened, that we started with the graph of x squared. We horizontally shrunk it, which means we squeezed it in towards the y-axis, and then we pushed this graph down 4 units, and there's our final answer. Well, let's check and see if that is the correct answer. Let's just call this new function some other name, h or whatever it is. And if we didn't know anything at all about these transformations, and we came in and we just graphed this quantity 3x squared minus 4, here's the graph that we would get that's in black here. Well, the graph that we got is right there in orange, and you can see that if I toggle this final answer here, this graph, black graph, on and off, you can see that we have the same answer, that through this sequence of transformations we obtained that graph. So hopefully that helps. I think it's kind of cool. I've always liked this stuff.